Good afternoon. Thank you for being here. So, my name is Danilo, and I'm part of the evangelist team in Amazon Web Services. I actually joined AWS almost 7 years ago now, so the cloud has changed a lot. And starting from 2014, when we launched AWS Lambda, I literally fell in love with serverless. I really think it's showing us how development is going to be in the future. It's the direction where we're going. And I also wrote a book that has been translated to Chinese and Korean. And I also work with my publisher to have a free ebook. So the last one here on the right is a free ebook that gives you an overview of the underlying technologies that can help you set up a serverless development environment. But today I'd like to focus on two topics. First, evolutionary architectures, and then how we can use evolutionary architecture with serverless. So serverless, I think, really is giving us the possibility to focus on what we want to build, without having to really manage all those complexity that lies underground below any complex architecture. But what I see sometimes is that developers, they are a little bit in doubt, because on one side, they know that they need to build something, so they should focus on the features they need to build. On the other side, it's very easy to fall for the habit. So we maybe know very well how to do some specific configuration, how to set up a database, and it's very comfortable to repeat this task again and again because we know how to do them very well, but that's stealing your time from more important stuff, that's building the features that you should do. And with serverless, we're getting back speed. So I remember a time before I joined AWS, where talking with companies, the IT department was seen as the bottleneck of innovation. So lots of requests, and then the IT department was the one saying, "No, we don't have time, we don't have the resources." I think now it's really different. I think now we can have the possibility to really bring back the IT department of every company to be the innovation center that can take the ideas and build the ideas, the prototypes, and bring the prototypes in production quickly. And this is, for example, a project that was done by Condé Nast in Italy. They built a photographic website for the Vogue magazine, where photographers can share pictures, and these pictures can be commented and eventually be taken and published on the Vogue magazine by Condé Nast. So serverless is really giving us speed. It's very easy with serverless to take an idea, build a prototype, and have a prototype that is already with some scalability, availability built in. If you don't do big mistakes, also some security built in because you don't need to use lots of credentials. But speed requires control. So when you start and you have your product first in production, how can you keep control of what you're doing? How can you keep the steer on so that you keep evolving the product in the right direction? So the big suggestion, and this also comes from our experience in Amazon, in AWS, is don't think of what you're building as software developer as a project, think as a product. And the reason is that projects, they bring you the idea of milestones. You are in version 1, I need to build version 2, all my focus is there, and then I have to build version 3. They bring you to think long term, even if sometimes there's lots of things changing under the hood. And product development is different. Product development is always focused to the customer of that product. You always think, how can I get better feedback? How can I get some customer delight when they use my product? And this is not anymore a straight line. It's really following a path that is changing anytime you get a feedback. For example, we release lots of features on AWS, and when we launch a feature, the day after, someone comes and tells us, hey, now that you released this feature, we really need to use that together with this other feature that you already have, otherwise it doesn't make sense. And you get the feedback and you start working on that. And the customer needs are never steady. They always change. You really need to look for the new direction that they are taking. Projects are really focused on reaching the next milestone. With product development, you really are focused on creating something that your customers are enjoying using. They get the maximum value out of that. Projects really focus to think about the cost of reaching the next milestone. So how many resources I need, how much time do I need to release the next version. Product development shifts the cost on the product life cycle. For example, if you build a car, it's not just the cost of assembling a car. It's the cost of maintaining this car on the street for the next probably 10 years, replacing the parts, having the possibility, a network of people that can supply the changing parts, and so on. We should think of software development in the same way. So when you release something, this has a lifespan, and it should be updatable. So the way you write the code, the way you use the different resources that you use should be pluggable, should be evolvable for the future. So in a way, projects really bring you to look into the past. So what I did for the last milestone, how should I improve? Products, they bring you to think about the future, what I'm going to do next, and how much will it cost to maintain what I'm building now. Normally, when we build a product, when we update a product, there are 4 main reasons. Either we add new features, or we solve some bugs, we reduce some defects. We want to reduce some risk, like security exposures, or we want to reduce some internal debts, like technical debt that you accumulate when you continuously update a product, and with the risk of having something that is not maintainable anymore. And normally we get feedback from different people, from different teams about this. So the business is telling which new features we need to add. The customer, of course, are telling us if there is a bug, if there's something that we need to solve. Security and compliance can show you where there is some risk that needs to be mitigated, especially with security. And the development team, the architects, are the builders that normally tell you, hey, we need to take some time to do some refactoring, otherwise we will not be able to keep the speed because the code base is not going in the right direction. What is often missing is a big link between the customer feedback and the business in a way that also the new features, that you're going to build are based on the feedback of your customer. This is not something that is not easy, especially at scale, especially if you have not 10 customers, but you have thousands or millions of customers. So think always of ways of collecting this feedback. And since this is not a project with milestone anymore, you can't plan a lot in the future. Stuff will happen, and you will need to be able to react quickly. So keep your team not at full utilization all the time. Otherwise, you will not be able to react. Normally, I would suggest keep 20–30% of the time of your team ready to manage something that is coming that you can really plan for. So when we want to evolve these products, we need to understand that we need to think about the evolution of the software as one of the requirements of software development. This is the definition from Rebecca Parsons in ThoughtWorks. And she said an evolutionary architecture is something that is designed for incremental change as a first principle. So a very basic translation that I did is that your first requirement when you build something is probably that incremental change should be there. So you should design everything you build to be updatable, to be easy to add new features and solve bugs. So we have this product that we want to evolve, and we want to reach some target. That's what we want to give to our customers. And at any point in time, we have multiple decisions that we can take. So what should I focus my energy on? So for example, should I focus on adding a new feature or doing some refactoring to reduce the technical debt? Should I improve the security or maybe the scalability or any other non-functional requirement of my application? So how can I decide what to do? So from a computer science perspective, this is an optimization problem. When we have a problem that we want to optimize something, so the value of what we do, and we need to clarify how to find an optimization. So this is where, when you have an optimization problem, you either have some way of finding the solution explicitly, or you need to explore the space of the solution. So somewhere there is the best solution. So this is what I want to do with my product. I want to reach that point, but it's not easy. It's unknown the direction that I should take, if I should focus on new features or on scalability or security. How can I explore the space of this solution that is almost infinite? So over time, there's been lots of different ways, but one way that I think it's interesting and it will bring us to evolutionary architecture is all those evolutionary algorithms that try to simulate Charles Darwin evolution to solve mathematical problems. I don't know if any of you is familiar with genetic algorithms, for example. The idea is to create a lot of candidate solutions. So normally you start at random and you create random solutions. So one random solution could be, let's focus all our energy on building new features, or let's focus everything on security or scalability. And then at some point I want to understand which of these candidate solutions is good for me. So to do that, we introduce a fitness function. The fitness function is a way that, in this case, you should probably agree together with the business, that takes all the possible actions and gives some value to those actions. And if you create a fitness function, then you can take all the candidate solutions, the ones that have a highest score for the fitness function, and discard all the others. And probably you're getting closer to the unknown solution. And then, when you are there, you can generate new candidate solution as random variation of the previous solutions. Again, you apply the fitness function. You take only the top candidate solution and you discard the others. And in this way, you get closer to the solution. This is a generic optimization problem that you can use for lots and lots of different tasks. And you alternate generating random solution and then selecting the best solution to get closer to the optimization that you want to do. The problem here is that for a software architecture, it's really difficult to explore the infinite space of all possible technical choice that we can make. So we can't really do automatic evolutionary algorithms to solve this problem. But we can still use the fitness function. And this is what evolutionary architecture says. Let's create a fitness function that tells us at any point in time how our architecture is improving or maybe going not in the right direction. So how can we compute a fitness function for an application? We can take lots of different metrics. For example, I can use source code metrics, like cyclomatic metrics. I can look for test coverage, performance metrics, security. I'm encrypting data at rest. I'm encrypting data in transit. If I have some secrets, some credential, how am I managing the rotation of the credentials, or am I always using the credentials for years, the same credentials without updating? And together, maybe with the business, I can give a score to each of these points, and I can just sum everything together, and I get a fitness function for my application. So in any point in time, I can create a fitness function. And the absolute value of the fitness function is not telling me anything, because it's some values that I define by itself. But when I do it multiple times, the variation of the fitness function going up or down is telling me if I'm going in the right direction or not. So I can use the fitness function to look at my current architecture, and then if I have to decide, should I focus on adding a new functional requirement, or should I focus on solving some non-functional requirement like scalability, I can just take my current architecture, compute the two different fitness functions for the two different scenarios, and get which one gets me closer to what I want to build and gives me a higher score. So ideally, if I create this fitness function, for all the releases of my application, I can have a graph like this that tells me, OK, this is my first release. Then I focus on improving the scalability, and this gave me a little bit more score in the fitness. Then I implemented the encryption in transit. Then I increased the availability, managing the state in a different way. And then maybe I managed also encryption at rest for all the relevant data that requires this kind of treatment. So this is a path that you can now monitor and understand how is it going. Actually, if we look at this fitness function, if people is here and they also like machine learning as much as I do, they maybe find that there's something similar in machine learning. Because when you create a machine learning model, normally to train a machine learning model, you create what is there called an objective function. And the objective function is a function that, in that case, you don't want to maximize like fitness, but you want to minimize. And the objective function in machine learning is computed by two terms. The first term is the loss that tells you, OK, I create a machine learning model to maybe do the forecast of the weather. The loss is maybe summing up how good is my model with the data in predicting the data that I already have. So maybe I look in the last 3 months of weather. I apply the model, and then I sum up the error or the square of the errors together, and that's the loss. So how, if the loss is big, my model is not working very well. If the loss is small, my model is very good in prediction. The problem of this approach in machine learning is that it can give you overfitting. So you can create models that work very well with the past data where you test the model, but then are not very good when you give you new data for the future. For that reason, normally in machine learning, we use another term that is called regularization, that takes into account how complex is my machine learning model. Because normally, if you create a machine learning model that is too complex, then it's very good in adapting to the old data, but not very good to work with new data, because it's really customizing its behavior for the old data that you have, and it's not extracting the real information from the data that you have. So regularization is a term that grows when you have something that is maybe too complex for this machine learning problem. And the sum of these two terms is something that you want to reduce. So if you add complexity to keep the objective function low, you need to reduce the loss a lot. So these double terms work very well. And this is similar also for fitness. No? In case of the fitness function, we want to maximize the value and the fitness of our architecture. But maybe to do so, we don't want to create a super complex architecture to solve simple problems. So we can add also a regularization term. So maybe every time I add a new microservice or every time I add a new database of some sort, I should add a regularization term that gives me, OK, if I add this, it really needs to improve the fitness of my application. Otherwise, it doesn't make sense to add complexity to my architecture. So for serverless architecture, to build something like this, we can start by managing the infrastructure as code. So by describing the whole infrastructure that I need for my serverless architecture, so the functions, the data store, the database tables, all in a single template. And this, together with the code, creates a whole description of my application into text files. We already saw also in the previous presentation that, for example, on AWS, we have the serverless application model, SAM, that is a way to describe the infrastructure of a serverless project. These 20 lines of code, for example, declare a function with some linking this to the source code. They use a policy. So as we said, we saw in the presentation before, never use asterisk or a generic configuration in permission. Security is everybody's job. It's not something that you add at the end. So as a developer, it's very easy at the beginning of a project to say, OK, I start giving all the permission, and then me or someone else at the end will reduce the permission. It's actually extremely complex to do that, because if you give lots of permission and then you don't know which one you are using, doing least privilege at the end, it requires more effort. So always start by no permission and add the permission that you need. It's much easier, and it's the best way to follow. And then so we create a function, we give some permission, we say that this function answers to an API with some specific path, and we also create a DynamoDB table, so a database table for the function. So it's an easy way to describe your infrastructure in just a text file. And then we can use the SAM CLI, that is the new name of SAM local that was mentioned before. Large companies like to change names. And with the SAM CLI, we can use this simple workflow. So we can start by initializing the code of our application with creating a function. Then we can use build to create the build, the artifact build of our application. Then we can package the code and deploy the code to the cloud. And we can iterate, build, package, and deploy as much as we want to create a continuous integration and continuous deployment architecture. In fact, you can put these 3 commands in any CI/CD tool and just have a very smooth serverless pipeline for your deployment. If you want, you can also publish this application to the serverless application repository. That is a way to share this application privately in your account or publicly with other people if you want to create something like an open source project. But let's go back to the template and the code. So now we know how to deploy this template describing our infrastructure and the code of my application in production. So the package and deploy commands will create a stack. It's the implementation of the template that we can use, and we can create multiple stacks for maybe test and production if we want. And then from the stack, we can get the feedback from the customer. As I said before, getting the feedback from any deployment that you do as quickly as possible is super important. I would say that the speed of a development team is really based on how quickly you can get the feedback when you roll something out in production. Because until you get a real feedback, you really don't know if you're going in the right direction or not. But let's dive in a little bit into the deployment part. So when you deploy something in production, we try to add some features on AWS to make it easier. And this is actually generic. We have some automation. But normally, you can deploy everything at once so that everybody's seeing the new version immediately. But this can be quite risky, because a few bugs always slip to production. So normally, we see our customers, they do canary deployment. And normally, we split canary in two categories. By canary deployment, I intend a canary release that works in two stages. So first, a small amount of my customers see the new version of my application. And then if it works, I roll this out to everybody. Linear is something where we slowly deploy to a growing number of customers. So maybe we start with 10%, then 20%, 30%, until we reach 100% of our customers. Now we fully can automate that for Lambda function, because we added an integration with our deployment tool called deploy. And during the deployment, the canary deployment, you can declare alarms and hooks. So with alarms, those are on AWS just CloudWatch alarms. So you can create alarms, for example, to check that your new function is working, your API is working with an acceptable latency. And if any of these alarms is fired, we roll back to the previous version automatically. And then we can also create hooks. And hooks are interesting because hooks are Lambda function that you can write with your own code. And by the way, it's the same hooks. They work also for containers. So our container service has a similar concept. And the pre-traffic function is a function that we trigger before, when you do a deployment, before this deployment is used by anybody. So before the first customer has touched the new deployment. So this pre-traffic function, for example, can do some final smoke test to see that everything works. And this pre-traffic function must do an acknowledge back to the deployment platform to tell, OK, everything according to what to my check works, you can go to the next stage and start the canary deployment. The post-traffic function is fired at the end of the deployment, where 100% of the customers are using the new version. And for example, can be used to annotate your Git repo to tell that this commit is actually going in production. Because often we assume that with continuous integration and continuous deployment, when I do a commit on Git, this goes in production. But actually, this can roll back for any reason. So knowing which version actually reach production can be quite interesting. But let's dive deeper into these two steps. So how can we use these functions to actually build an automatic way of computing our evolutionary architecture fitness? Well, we can use these functions to do some automatic computation on our side. So for example, since everything is deployed here in a stack, in a CloudFormation stack, I can do stack introspection and see what are the resources in the stack. So there are functions, there are S3 buckets, there are DynamoDB tables, or anything else. And then I can do some check in my function to check that these artifacts, these resources, are actually following the best practice that I want. So are they using, are my S3 buckets all encrypted? Did I enable versioning in my S3 buckets so that if someone deletes a file, I'm able to roll it back? Can I, for example, S3 buckets by default can also be accessed using non-encrypted HTTP. So you can disable that. So you can do a check to avoid that. And my DynamoDB tables, are they designed to be scalable or not? And so on. We also have a service to do that. It's called AWS Config, and was mentioned in the first session in the morning. And AWS Config can do automatic tests on lots of AWS resources, for example, to check that you're using S3 or DynamoDB or Lambda function in the correct way. So you can decide, OK, I want to enforce that all my S3 buckets are SSL request only, and AWS config can do this check for you. So you can get this result and use this to compute the fitness of your application. So basically, these two functions can be used to do three things. First, analyze the architecture from, I would say, from the inside. Then can publish the fitness metric, for example, on CloudWatch, so that you create a metric like you get CPU usage or memory usage, and you get fitness of your application. And then you can update a product dashboard that automatically will give you a graphic like this in your dashboard to understand if any deployment you do is going in the right direction. And this will be part of your global product dashboard that tells you how many concurrent users you have, how many stuff you're doing per minute, and so on. To add this canary deployment to a function is relatively easy, because this is the same template like before. And you can just specify a deployment preference. In this case, canary 10%, 5 minutes. That means that the new version of the function is given to 10% of the invocations for 5 minutes. And then if everything works, it's given to everybody. And then you can set a list of alarms. Those are CloudWatch alarms. So for example, if there is an API error, or if the API latency is too high, roll back the deployment. And then you can define the pre and post traffic hooks. Those are just Lambda functions that you can link here. In this way, you can get not just the speed of serverless, but also keep the control of your deployment and if you're going in the right direction. So let's do a quick demo, because there was lots of theory in these slides, and let's see if this makes sense in practice. So this is a sample project that can you see? No, because I have to ask. OK. So this is a sample project that I have. And I have 2 functions. And these 2 functions are just test functions. They're actually just printing the name of the function and the version of the function. The second function is exactly the same. And then I have a template doing the deployment. The template is creating some resources on AWS. So I have an encrypted bucket, an unencrypted bucket, a DynamoDB table that is encrypted, and one that is unencrypted. The functions that are defined as an API. The first function answers to /first. The second function answers to /second. And then I have the pre-traffic hook function. This is a little bit more complex in the definition, because I need to give permission to call, for example, code deploy to acknowledge if the deployment should proceed or not. And then needs to be able to test the function. So I need to be able to invoke my first and my function and my second function, so that I can do a smoke test before the deployment. I give access to CloudFormation, so I can list all the resources in my stack, and then depending on the resources, do my own test. I can publish metric on CloudWatch, and then I can check, for example, encryption on S3, describe a DynamoDB table, and so on. We're almost there. So that's the main purpose. So this is actually already deployed. And let's start a deployment now. So if I do package, this is packaging the application. Oops, I'm in the wrong directory. I do package, and then I can do deploy. And this is now sending the updated version on CloudFormation. If I go on CloudFormation, apart from I need to reload it, we have here the list of the stacks. So in this case, I have this evolutionary architecture. Let's make it a little bit bigger. That is my application. I click here. I can see events. And here I can see I can trace the deployment as it happens. If I go back on the demo, I see that when we do the deployment on CloudFormation, the first step is to create a change set. So compare what is already there and what I want to change. And then we apply the change to do the change. If I go on CloudFormation here, and now I reload, I should start to see that there is an update in progress. And if I go on code deploy, I can actually check the deployment of my functions. I see that there are 2 deployments in progress. And this is how the deployment is going. So the pre-deployment validation is the pre-traffic function that is now computing the fitness of my architecture using all that introspection. Then we start the traffic shifting, and then we go to the post-validation of my deployment. And this is the same for the second function. So if we look here, we should understand which is which. So this is my first function. You can see it here. And it's a linear deployment, 10% every 1 minute. So we start with 10%. After 1 minute, we have 20% of the invocation to the new version, then 30%. And in 10 minutes, this will deploy the new version. We are now at 20% here. If I go on the other deployment, this is the other function. This is using canary 10% 5 minutes. So for 5 minutes, it will stay on 10% of the user, of the invocation, actually. And then it will roll out to 100%. And to see if this works, we can go here. I have a couple of scripts that they are just calling the function every half a second. So here on the left, you see that this is function 1, and this is function 2. So you see that there is version 4 is where most of the stuff is. And now when the deployment goes on, we should start to see version 5 more often. So this is my first function. You can see it here. And this is my second function. I can make it bigger because the name of the function is a little bit longer. So first and second function. So if we go back here, we see that, for example, my second function is now at 30%. This is the first function. And in fact, I think now we start to see 5 appearing a little bit more often here in the invocation because the deployment is rolling out. While here is still 10% on version 4, and then after 5 minutes, we will roll out. So while the deployment goes on, let me just have a quick look at the Lambda function that is doing the pre-traffic hook. And let's make this a little bit smaller. So here, I'm using the AWS SDK. This is written in Node.js. I'm creating lots of service objects because I'm using lots of AWS services here. So the deployment service, Lambda, CloudWatch, and so on. And then I have like a utility function. This is just to manage pagination. So our APIs are REST APIs. So if they return a list, they need to do pagination because you can't have 10,000 buckets in a single API call. So I just created an utility function to manage pagination. Then this starts to be interesting. This is list stack resources. So this is calling CloudFormation to list all the stack resources that are in my stack. So this is completely generic. It's not tied to my application. I have 2 functions and some other stuff. But you can use the same function with any CloudFormation stack. It will look at any resources that is there, and then it's doing all the check for the single resources. And then there is a test function that is testing my functions. And it's assuming that these are APIs. So it's calling the function and checking that the status code, the HTTP status code, is between 200 and 300. This is the range of correct answers for a new deployment. So if this fails, they are changing the deployment status to fail before this is released to any user. Then I have a few functions that do specific tests. So this is testing that DynamoDB has encryption enabled. This is not implemented. It's checking that DynamoDB has the backup enabled, that S3 has encryption at rest, and so on. And this is, when I was writing all of this, then I realized that the AWS config is already doing most of that. So what I did a different thing. I went on the AWS config console, where you can check rules, and I enabled a few rules here. So I want DynamoDB to use autoscaling, I want S3 to use encryption, and so on. And if you do that, then you can just check the compliance of a resource. So on all the resources in your CloudFormation template, you can just count the call this API that is get compliance details by resource, and you get if this bucket, this DynamoDB table is compliant with your specification. And if it is, you give 10 points in your fitness, for example, for any compliance that you get. So I'm creating the fitness function as an addition of all these tests. And then I'm running all the tests almost all at once. Using JavaScript, I create a list of promises, and then I launch all the tests at once because I don't need lots of computation. And this is how I work. So I have the list of the resources in my stack. And then for each resource type, I have my specific test. So I want to test for any S3 bucket, I want to test encryption. And then I want to do a generic compliance test with AWS config. For any DynamoDB table, I want to check encryption and backup. And then I do a generic compliance test with AWS config. For any Lambda function, I want to run a mock test to see that it returns the correct answer. And then I check the compliance for Lambda function. And then the promise all will execute all those tests in parallel. And then I get the final result. So I think now the deployment is probably almost done. No, still going on. But on the left, we're almost always in version 5. Here on the right, also, I think the Canary deployment just terminated. Now we switch everything to version 5. So my deployment is probably the Canary deployment has succeeded, and the other deployment is, I think, at 70%, so almost done. If this deployment were also publishing a metric, so if I go here on CloudWatch, sorry, I created, let me make this a little bit smaller because the screen is different. I created this dashboard that is showing me the fitness of all my fitness function. And if you see here, this is the fitness of a few deployments that I did. And this is the latest fitness. And as you see, my fitness is actually dropped. Can anyone think why my fitness is dropping? It's not easy because I realized that today. Because I was creating a DynamoDB unencrypted, but we changed the default value a couple of months ago. So now all DynamoDB tables are created automatically encrypted. So I was getting a higher fitness without even knowing. And then I changed the template to explicitly make a DynamoDB table not encrypted. And that dropped my fitness because it's not encrypted anymore. So I changed this in the unencrypted table. I had to add this to say that I don't want encryption because the default has changed over time. So I think now you have a better understanding of how you can measure the fitness of your architecture, of how evolutionary architecture can create a dashboard where one or even more all of your application are going with their evolution. And this is all the code that I was quickly showing is open source here on GitHub. So if you want, you can have a quick test and see how that works. And thank you.
Thank you very much.